Hi, Hillary here again. In this video, I would like to go over some ways to create great slides displaying the results of a research article you're reporting on. It's not an easy thing to sometimes understand these results, and it's even a little bit harder to put them into some kind of simplified visual and simplified narration that anybody can understand. In previous videos and YouTubes and modules and readings, you've gone over things like the significance of the results, whether the variables are categorical or numerical, and what kind of biases might enter into those results. So as we put together our slides, we will keep all those things in mind. And we'll look at the most straightforward ways to use Google Sheets or Excel to get some good graphics for your slides. What we're going to go over in this video are 4 different types of graphs you might want to make and why you would choose one or the other: the bar graph, the pie chart, the scatter plot, and the step chart. The bar graph is if you have categorical data to put into categories. The pie chart if you have data that is divided 100% into different percents. Don't use a pie chart unless you have something that adds up to 100%. A scatter plot a scatter plot or a line graph would be if you have a continuous variable along the x-axis, maybe time, maybe concentration, maybe volume, and a step chart might be again a time per day, things that happen every day, once per day, and you'll see that too. But the idea is to find graphs that simply represent the data and then to add a story. Put a story to your data so your listener can really understand the results well. Let's start with those beautiful Sambucus berries. You'll remember that we put together some great slides, first showing the background. Remember, the good phenols are on the left and the toxic cyanogenic glycosides are on the right, and both of those are in Sambucus. And then the methods. The researchers picked some wild elderberry fruit, and they've created 5 different preparations: a liqueur, a juice, a tea, a jam, and a control, which was just the crushed berries. And then they used a HPLC mass spec to analyze these different preparations for levels of beneficial compounds and levels of toxic compounds. So let's see what they found and how I am going to tell the public what they found in the most clear way possible. So here's that same article again, that exciting Croatia picking wild berries research that these people did. And we'll scroll down. There's the introduction again, there's the materials and methods, and now we're in the results and discussion section. You'll see that the researchers themselves made a nice little graphic, but for this assignment you cannot use graphics straight out of the research. I want you to put your own explanation, your own emphasis, your own creativity onto the data and present your own graphics. So do not just copy and paste from the article. Here's the first table. Usually the first table is not the table that you're looking for the results. They usually give just some background information on the participants or on the samples, and in this case this table just gives me the fact that there was in the control, the juice, the liqueur, the tea, and the spread, they found all these compounds. That's what the plus means. The first 20 some are all positive beneficial compounds, and this last one is the toxic compound. So it was found, all of them were found in almost all of the different preparations. But while we're here, I do want to point out one funny thing. It's just a great illustration of how careful you have to be when you read these results. You will notice that one of the good phenols is called cyanidin 3-O glucoside. But the toxic compound that we're worried about is called cyanogenic glycoside. So the glucoside is good, the glycoside is bad. And so you have to be very, very careful and watch those terms. This is a really detailed chart. And here are some of the complications and decisions I had to get past as I was deciding what specific data to make a visual, to make a graph about. First of all, they're giving their results in milligrams per kilogram, and I assumed at first that was parts per million, the concentration of phenol, for example, in the liqueur. But when I read in the text, it wasn't that actually. It was the milligrams of phenol in per kilogram of berry required to make the liqueur. So they were trying to standardize across the different preparations the concentration. That's why they did it per kilogram of berries that went into the preparation as opposed to per kilogram of the preparation. It's a detail, but it's kind of an important detail in the overall scheme of things. Secondly, I had to understand this new Duncan multiple range test. It's a different statistics test. I looked it up for a while, couldn't figure it out too well, but did figure out that it tells me that these little superscripts A, B, C, and D are telling me that's where the significant results are, and so basically there's significant results throughout the table. Thirdly, I had to decide, how do I simplify all these numbers to make a good presentation? So I decided to go with the most important phenol, in other words, the most important beneficial compound. That's the cyanidin 3,0-sambubioside at 328 milligrams per kilogram, the largest amount of any phenol in the Sambucus. I also want to include total phenols, or total beneficial compounds, and total toxins. So there'll be three numbers, so I'll make three graphs to, in a quick way, present to my audience. Here's a little bit about the specifics here, and here's the total picture as well. So all the information I want is in this bottom piece of the table, so I'm just going to take a screenshot of it and take that screenshot over to Google Sheets. That way I'll have all the data in one place. So off we go to Google Sheets, new Google Sheets, blank spreadsheet, and now let's insert an image. Insert image, image over cells. Browse my screenshots, and there it is. Perfect. And I'll just move it over to the side here where it's a little bit out of the way. I have all the numbers that I need. And here I'm putting in the values for cyanidin 3,0-sambubioside, controlled juice liqueur, tea and jam, 32.81, 47.8. If Google or Excel accidentally lop off the 0.0 that was in a data point, you can always fix that by going to these 2 points here and clicking increase decimal place. As chemists, we want to maintain our significant figures. Okay, so I fixed up the table. Google Sheets is usually pretty good about guessing what kind of graph I want, so let's see how they do. I've highlighted the data I want in my graph. I go to Insert, I go to Chart, and it's working, and that's it. They guessed wrong. I wanted a bar chart, so let's go over here to the chart editor that came up automatically and switch to bar chart. There we go. But look at all the things they did right. They've labeled my x-axis, which is my independent variable, and they've labeled my y-axis, which is my dependent variable, because I had put those two labels up here. Let me interject here that for those of you who are new to Excel and Google Sheets, to make these things work, you have to put the x values in the first column or the left column, and the y values in the second column or the right column. Then your graphs will come out right. They even came up with a title for me, which is pretty amazing. So now I'm just going to customize the look just for fun. Customize, series, change the color to that good old Sambucus purple, and that's it. Everything is there. If they hadn't put an x-axis in, I can always go to here to horizontal, under Customize, Chart and Axis Titles, and change the title to something, preparation of berries, for example. I can change the font size if I want, and see what happens if I make it even bigger. And I can change the font size on the y-axis as well. If I click on the y-axis, this comes up automatically, or I could find it under Customize. Let's change that to 16, make it a little easier to read because this will be possibly a slide presentation in front of people. And I can center this one right there, and I can change the color if I want to. Let's go for the brown. There we go. Well, part of my story is, does this main phenol, cyanidin 3,0-sambubioside, follow the same pattern as the total phenols in the different preparations? So I'm going to make another chart the same exact way with total analyzed phenolics. In column C, I put the total phenols data. So I'm going to highlight that column using my command bar. I'm also going to highlight this column. And let's see what happens when we insert a chart this time. Wow, right away. The right kind of chart. And by comparing these two charts, we see that total phenols does follow the same pattern as the best phenol, cyan 3,0-sambubioside. And so that can be part of my story. The phenol total is highest, of course, in the control, and worst for juice and tea, and best for liqueur and jam. There's one last thing I'd like to do, which is put in the same graph with the total phenols, the total good stuff, also the total bad stuff. So side by side bars. Once again, I've highlighted the 3 columns of data that I would like in my chart. So let's see what happens. Insert chart. Boom. Okay. There we go. We can barely see the toxins in the control and juice, and we can't see them at all in the liqueur, the tea, or the jam. I also see that this time they did not give me my y-axis, so I'll have to fix that, but they did give me a legend here, a key to the colors, which is great. But these 0.8s for liqueur and jam, and even the 3.8 for tea, have completely disappeared. There is a way that I can fix that. Customize from the very beginning. Click on the chart, click on the snowman 3 dots, click on Edit Chart, Customize, Chart Style, and click on 3D. And now you can see that there actually was data, a very little bit of data, down by liqueur, tea, and jam. There's one more thing I can do, which is to actually put the numbers in there. To do that, I go down to Series and do Data Labels, and there they are. Maybe a little busy for you, but it's kind of nice too. In Series, I was at Apply to All Series, that's where the data labels came in, but I can also change the coloring. I'll do the total phenols as a nice purple, and I will do the toxin as red. That makes sense. Well, there's one thing that Google Sheets does not do very well, and that's error bars. They can do error bars, but they all end up the same size. So I've moved to Excel to show you how to get error bars. And here is the original sambubioside data with also the standard deviation. And you can see each standard deviation is different. It's not all 10%. It's not all 25. It's all different. So I need to use Excel to show that. I'll select the data that I want, and I will insert a bar chart. And there it is. To add error bars, I follow this procedure. Click on the chart, click on Chart Design, go to Add Chart Element, and go to Error Bars. But I can't just do standard deviation. I have to go to More Error Bar Options. And then I need to go to this third option here and customize it. I'm going to specify the value, and now it's, remember, standard deviation is plus or minus, so my pluses are going to be this set of values, and my negatives are also going to be this set of values. And then I'll say OK, and there they are. And you can see the arrow bars. I could change the format of them, the color and the size if I like. To do that, I go to Paint, and then I can play. Change the color to a nice purple, change the width to a bigger amount. All right, let's see what we got. And there are my error bars, my standard deviations. And you can see they're just standard looking standard deviations. They're good to have in case somebody wants to know, say, what was the standard deviation of this study? And so I'll probably keep them on at least one of my charts. Well, the truth is, I don't remember all the details about how to put in error bars and change the fonts and all those types of things every time I come back to Excel or Google Sheets. So very often I just Google the question, how do you put standard deviation bars in Excel bar graphs? And there'll be a little YouTube and it shows me how to do it. So full disclosure, use Google whenever necessary. Okay, well, after some work, I have my slides ready. You can see there's 3 of them here to tell my story about the results of this study. I did have to do a little bit of dimensional analysis here to translate something that was in the text into something I could share more easily. I translated the milligrams of toxin per shot into parts per million because in another part of the text they gave me an idea of what was a safe parts per million for the toxin. So they hadn't done that conversion, so I did the conversion for both the liqueur and the juice. And also I had to grab a citation, so I'll put that at the very end of my slideshow because I am going to refer to somebody else's work very quickly in my story and I don't want to lose that citation. So my 3 slides are ready to go. As you see, I placed them right after the method slide, so after I explain the methods, I'm going to tell the story of the results, and this is how it might go. And here are some fascinating results from the Sambucus study. This chart shows the level of cyanidin 3-O-sambubioside in the different preparations. Remember that the control involved just crushing the berries and showed a level of over 300 milligrams of the beneficial phenol per kilogram of berries, whereas the preparations, which all involved heating, did lose a level of this common beneficial phenol in the Sambucus. However, despite the heating, the liqueur managed to retain almost a third of this beneficial phenol, and the spread managed to retain almost 25% of the beneficial phenol. Well, cyanidin 3-O-sambubioside levels is interesting, but an even more important part of the story is the level of the total phenols, all the beneficial compounds in the berries. And you can see that the control contains over 900 milligrams of total phenols per kilogram of berries. The preparations all do also drop in total phenol due to heating, but the liqueur and jam manage to retain more than a third of the total beneficial phenols in the raw berries. Now let's talk about the toxins in elderberry, another part of the story. Cyanogenic glycosides are a family of toxins that are found in many foods, including apple seeds, cassava, almonds, and elderberry. The particular cyanogenic glycoside in elderberry is called sambunigrin, and as you can see, the levels in red are quite low, and they decrease even more upon heating. But are they low enough to be safe? Well, a safe level of sambunigrin has been determined to be 0.04 to 1.2 parts per million concentration in a food product, and the concentrations in the liqueur, for example, are 0.06 parts per million, and in the juice are 0.15 parts per million. So that's quite a safe level. In comparison, apple juice made from fresh apples, not processed, will have a higher level of cyanogenic glycoside, perhaps 1 to 80 parts per million. You don't have to worry about apples, however, because studies have shown that you need to eat at least 80 apple seeds, chew them and swallow them before you feel any toxic effects. This type of hydrogen cyanide poisoning that results from eating too much cyanogenic glycosides is more of a concern in Africa, where the toxin is found in cassava, which is a staple of the diet, and if the cassava is not cooked well enough or long enough, will retain high levels of the toxin. The takeaway for this is if you're preparing your own elderberry preparations, make sure to cook them According to this research, the levels of toxin in homemade elderberry preparations should be just fine. However, remember that this is Croatian elderberry, so it would be good to look into studies of American elderberry, say from Maine or Canada or California. So I thought in conclusion that this was a very strong study. I believe the results are very solid. The only difficulty I found with the study was that all the berries were collected from just a few bushes in one spot in Croatia. So who knows, maybe there are very different levels of phenols and toxins in Sambucus bushes in different parts of Croatia and different parts of the world. So that would require more study. So to wrap everything up, the liqueur and jam recipes managed to retain over a third of the beneficial phenols in Sambucus berries and also demonstrated a very low level of the toxin. In fact, a very non-dangerous and safe level of the toxin was found. So we went over bar graphs in detail. Now I'll quickly go over why and how you might want to use a pie chart, a scatter plot line graph, or step chart. For the pie chart demo, I've selected some data from the American College Health Association summary. Now, it's not a peer-reviewed study, and so you may see some difficulties with the results, actually. Here are the results of a survey they did asking college students how often they have vaped in the last month. Let's just see what happens. I put it all up on Google Sheets. And we have it selected, so we go to Insert, Chart. And they gave me a pie chart right away because they saw that my results add up to 100%. That's when you use a pie chart, if your results add up to 100%. So for example, of these three subjects, which do you prefer? Math, science, history. Amongst all the respondents, maybe 40% will say history, 30% will say math, 30% will say science. It will add up to 100%. But if the question is, have you ever lived in a foreign country? Have you ever lived in a different state? Have you ever lived in a different town? People will have done multiple of those things, so nothing will add up to 100%. It will add up to much more than 100%, so you could not use a pie chart in that kind of a case. I notice here that the little green segment there doesn't have a label because it's so small, so I'm going to play around and customize it, see what I can come up with. You may have noticed in these results that only 19% of college students report ever having vaped in their life. If that strikes you as low, it could be because of a bias in the survey. Again, it wasn't a peer-reviewed study. They only got 17% of the surveys that they sent out back, so there may be a voluntary response bias going, or maybe the survey respondents just did not want to admit to vaping. Moving on to line and step charts. This study looked at the level of organophosphorus pesticides in children based on their diet. They took children who ate an entirely conventional diet, no organic food at all, and they looked at them over a year, every season, fall, winter, spring, and summer. They took a 2-week sampling session where they sampled the urine of the children every day. And in the middle of 2 of those sampling sessions, they put a few days in where they substitute their entire diet from conventional to organic and looked at the effect that that would have on the level of pesticides in their urine. Their data is down here. And as you can see again, table 1 is not the data we want. This is the data here, and it's a little bit hard to read. So it will be important for me to recreate a graph that gives some of this information in a simple, presentable way. You can see that these graphs are box and whisker plots with the quartile ranges being shown, and also the little line in the middle of the box is the median. I am going to just use the median for my data, so I'm going to extract the median for days, for example, days 1 through 16, to show one example of one sampling session where they took the middle 5 days and substituted organic food. I'm also only going to use the median value as a representative value, but do note that the values do vary widely amongst the 14 children. And another complication is that on this particular pesticide, MDA, they didn't use a straight up regular scale, they used a log scale. So this is 1 or 10 to the 0, and this is 10 to the 1. And so each of these little lines are going to have to kind of extrapolate exactly what number they are referring to there. Happily, this other pesticide, TCPY, they used a regular scale, so I'll be able to extract the data a little bit more easily. To be honest, I do have some questions about this data because each one of those black dots represents an outlier. And there's a lot of outliers on the days when the children were eating organic food. In other words, they didn't all get rid of their pesticides in their urine on those days. In fact, 4 or 5 each day showed a fairly high level of pesticide still. And there was only 14 subjects. So that's an interesting question. I would have to read very carefully and make sure that the data actually is showing what they're saying it's showing. But if they are showing what they're saying it's showing, then this is how I would translate it to a graph. Here's the data recorded in Google Sheets, the number of the days 1 through 16, the MDA pesticide and the TCPY pesticide. So let's just grab it all and see what Google Sheets does with it first. Insert chart. And I get a line chart. A line chart is not bad, and it clearly shows that for the MDA pesticide, there's my legend, the MD pesticide definitely drops. The TCPY takes a little longer to drop, and the levels of pesticide go up after the children start eating non-organic food again on day 9. Now, remember that they only sampled the urine once a day, so instead of a line chart, I may choose to use a step chart. Let me get that for you. Here, edit chart, setup. I don't want a line chart. Let's try, move my face out of the way, a step chart. And that shows both of the pesticides, the TCPY and the MDA. And you can see them both at the same time. And that more accurately reflects the fact that there was only 1 urine reading per day taken. So the line charts and the scatter plot charts you've most likely done in chemistry and biology. They're very similar. I won't go into them now. I think now is the time to end this video. So, in conclusion, make your own results chart. Do not copy and paste from the paper you're reporting on. Make your own results chart. Choose the right type of chart, bar, pie, etc., and turn your results data into a story for your listener. Have fun and be creative.